Let's see this problem, snake and ladders. You are given n into n integer matrix board where the cells are labeled from 1 to n square in a Boström style. Okay, this is Boström style. That means in first row it is in increasing order, second row it is decreasing order. No need to think much. Starting from the bottom left of the board, that is board n minus 1 to 0. And the altering direction each row. You will start on row square 1 of the board. In each move, starting from a square current, do the following. Choose a destination square next with a label in the range current plus 1, minimum current plus 6 n square. Okay, so either it will come now in the range. What will be its range? For each dice there are value of 1 to 6, so either it come 1 2 3 4 5 6, its maximum value will be 6, or it can reach to n square. So this is the range. This choice simulates the result of a 6-sided die roll. That is, there are always at most 6 destinations regardless of the size of the board. If the next has a snake or ladder, you must move to the destination of the snake or ladder, otherwise you move to next. See, if next is 2, there is ladder, then we have to move 15. There is a snake, its mouth is on 17, so I will move to 13. Okay. The game ends when you reach the square, n square. So if we reach on 36, this is the destination. A board square on row R and column C has a snake or ladder if board RC is not equal to -1. See, this has been given the list. Wherever is -1, there is no snake or ladder. Okay, there is 35. See, 1 2 3 fourth row here. This one is 14. For 14 it is going on 35, so it has been given here, its value will be 35. Like for a snake also, it has been given for 17. For 17 it will go on 13. Okay, its value is not -1 now. The destination of data snake or ladder is board RC. A square 1 and n square are not in the starting point of any snake or ladder. So it is given, that means from first position directly we can't reach to 36, or it can't, just a snake will be there on first position or on 36 also. It is our starting point and destination, so there can't be any ladder or a snake. Note that you only take a snake or ladder at most once per move. If the destination to a snake or ladder is the start of another snake or ladder, you don't follow the subsequent snake or ladder. That means we have to just follow once for each move a snake or ladder. See, if on 15 also there is coming another ladder, then we don't have to follow that ladder. Just one ladder move is fine. For example, suppose the board is -1 4, -1 3, and the first move you reach destination square is 2. You follow the ladder to 3, okay, but do not follow the subsequent ladder to 4. That means once only you have to move. Return the least number of moves required to reach the square n square. If it is not possible to reach the square, return -1. Okay, we have to find out minimum number of moves from a starting position it will take to reach the destination, that means n square. If it is not possible, then we have to return -1. Okay, let's see its explanation. I have taken one example here for the test case, which input has been given in the form of list. This is the list which input has been given, and I have created this board. This is Ludo board now. There is a snake and ladders. So like this, -1 was in first list, so all are -1. Second list also all -1. Third list also -1. In this list, -1 was there, then 35 -1 -1 13 -1, and this was all -1, and this was -1 15 -1 -1 -1 -1. Okay. So now this board has been formed. Okay. Now from where we start? What is our starting position in Ludo board? This is the starting position. We will start from here. Okay, so what we will take its position equal to 1 and move equal to 0. Okay, this is the starting point. What is the approach to solve here this problem? See, its position and moves, we have to store two value, because what will be our answer? Our answer is how many minimum number of moves to reach, this is final position, to reach the final position. So what I will take? I will take one dq for position and moves. Okay, and I will store here each position and moves. And in dice, how many times we can throw? There are six rolls. That means in dice, what is its probability? 1 2 3 4, 5, 6. If we roll a dice, then these numbers can come 1 to 6. So for each position, we have to check for each throw of dice what will be its next position. Okay, so what we will do, and for see, for some position here it has been given ladder and one a snake. It can give another snake also, but for in this example only one snake is there. This green color is a snake and this is the ladder. So if you go on position 2, you will directly reach on position 15, and if you go on position 14, then you will directly reach on position 35, and if you go on position 17, then you will reach to 13. A snake reduce the move, no? So this is the mouth of a snake and this is its tail. Okay, so now see how will we approach. So what we will do, we will store this one now in one set, in visited set. Its all positions will be stored inside a visited set. We will define one set, and here what we will do, we will store all positions, all new positions. Okay, because for each position if you have reached now, so we need minimum number of moves, and we need to store one more dq. This will be dq, so just name it q only, and we will define one q, that will be dq. This is q, this is dq. So in both direction it can be popped and pushed. Okay, appended. So in this q, what we will store, this will store all position and moves, all new position and moves. Okay, so here this is the position and moves. Our final target is what, to reach the destination, to reach the destination in minimum number of moves. So what we will store inside of this queue, which whatever moves is minimum, for that only we will store its position. Because see, if you are reaching like 9 in 2 moves, or I am just taking an example, and you are reaching also 9 in 4 moves, then whom will you store inside of this DQ? Of course you will store this one, no need to store this one. Why? Because our target is to reach in minimum number of moves. So we have to store the position whichever is taking minimum number of moves, and we will also store same position inside set whichever is taking minimum number of moves. So this is the criteria for storing inside of this visited set and inside of this dq, qdq. Okay, so inside of this queue only those position will be stored whose moves is minimum. For the same position there can be two different moves, so we have to store only those position whose move will be minimum. Okay, now see, so this is the case of set and queue. So until our queue is what, until in our queue now. So actually, mm, just see another way, when will we come out of this whole program, when we have reached destination. Okay, so when we have reached the destination, so we will have to come just outside of this program and return the minimum number of moves. That will be our answer. But we have to check for each move, we will have to check for each position and for each move. See, it can be case like if we start from 1 0, this is position and move, position and move. So in dice there are 6 moves, 1 2, in dice there are 6 throw, 3 4 5 6. So from position 1, new position can be what, either 2 or 3 or 4 or 5 or 6 or 7. If our initial position is 1, the new position can be 2 3 4 5 6 and 7. So what we will do, we will store each position inside of this visited set. So this new position will be 2, 3, 4, 5, 6, and 7. And see one more thing, whenever there is some ladder or a snake, so we will not store this 2. What we will store, because when we have gone on 2 now, we have reached on position 15. So don't store this position 2, store here position, this will be 2 fine, but here inside of this set store position 15, because here on position 15 we have reached in just one move, and inside of this queue we will store all the position and its moves. So what are the positions and moves inside of this queue? So see, we have a stored inside position and moves format. On first move, if it has gone on 15, then it will be its value of position and moves 15 1. And if it is gone on 3, then its position and move will be 3 1. And if it has gone on 4, then its position and move will be 4 1. And for 5, similarly 5 1, 6 1, and 7 1. Okay, so this will be the queue created. Okay, and its visited value are 15, 3, 4, 5, 6, and 7. So all has gone in a single move. This is the case of if dice can be 1, 2, 3, 4, 5, 6. So these are the possible moves, and these are the visited positions. Okay, so for each queue position and its move, we will check next dice throw. See, we have checked this one for 1 and 0. Our initial position was 1 and 0, and next case again I will take 15 1. Our position is here 15 and moves is 1. So for each 15 1 position, I will again throw the dice throw. Dice throw can be 1, 2, 3, 4, 5, and 6. Again we will store inside of this visited. So see, 15 and moves, 15 is the position, so its new position can be 16, 17, 18, 19, 20, 21. See, but if it goes on a 17, then there is a snake mouth, you can see on 17 there is a snake mouth, so it will go on 13. So from here it will go on 13. For 15 now we are calculating. So for 15 these are the new positions 16, 13, 18, 19, 20, 21. So for all moves will be number of moves 2. So inside of this queue, again this will be stored like this, 16 to 13 to 18 to 19 to 22 and 21 to. These are the possibilities which can go after it has gone on 15 in two moves. And for again for each case we will calculate if our initial position is what, next position is 3 1, so we will calculate for 3 1 also. Here position is 3 and moves is 1, so again I will throw the dice and it will come 1, 2, 3, 4, 5, and 6, and new position will be calculated. So new position will be like this, 3 plus 1, 2, 3, 4, 5, 6 we will do. And whatever already inside of this queue now, inside of this visited, because we have to put all inside of this visited here also. So here visited was, we have already taken 15, 3, 4, 5, 6, and 7. So whatever is inside of this set now, we don't have to take, only unique move we have to take. So 16 is not, 13 is also not, 18, 19, 20, 21 all will come inside of this visited set. But see, if for another lesser number of moves like 7, it can come 13 also. For 7 plus 6, this can be the case now, if we take 7 1, then if we throw dice and it comes 6, then it will also come 13 here. but we have already taken inside of this visited set 13 here, so no need to consider this move. Okay, so we will just store this move, whatever has come inside of this set, we don't have to repeat again and put that inside of this set and in this queue also. So like this, whatever position and moves are stored inside of this queue, I think there will be always six. Yeah, there will always be six positions and six moves. See, in this queue there will be always 3 3 6. Initially also 3 3 6. So each we have to pop also, and we have to calculate the next position and its moves, and we have to push inside of this queue. Actually, inside of this queue now, for 15 there are six cases. For 15, for 3 also there will be six cases. So total n square possibility can be inside of this queue. It can be like that, for each move there is unique. So total for n number of moves, actually n is the number of rows inside this board now. So for there can be total n square possibilities. For n square we have to check 6 times. So like this, we will check for each move what can be its next move and its position, and whatever has come inside already in this visited set, we don't have to take that one. We just have to take the minimum number of moves for each new position. So that will be stored inside of this queue. And what is our target? To reach on 36 here for this example, to our destination. So whenever its destination comes like 36, and in this case there are four moves, so whenever this one will reach now, initially whenever this initially it will reach, then this our should be the answer, our answer should be this number of moves. So this will return here moves. So this is 4. So in this case this will return 4. Like this, we have to just check for uh, total n square. Its worst case can be n square, but it should be in the range of n square, so its complexity will be like n square. So just see in this inside of this program, let's see its code, a snake and ladders. So here I already have explained. So now see it's inside of this code. Let me put this picture here. Now at first I will find out the length, that means total number of how many lists are there or how many columns are there, length of this board. This will be total number of rows or total number of columns, because here it has been given inside of the list format. So total 1 2 3 4 5 and 6 lists are given, so its length will be 6. Then actually here I will take position for each, like this is 1 2, its position number is 12 11 10 9 8 7, like this now. So I have to find out its row and column value, because see here all inside every row, what numbers are not in increasing order, some are in decreasing order, some are in increasing order. So I will have to accurately find out number of what row value and column value. So I will define one function for get position, accurate position this will be, and some position I will pass here. This will be integer value, and it will return two value of integers, one row and another column. Okay, just see here now. So initial row I will take like position minus 1 divided by n. This will be integer value of this row, and column position minus 1 modulus n, the remainder of that position. See what will happen if we go for, see for this um, here this row 1 2 3 4 5 6, its row value should be, because inside of this list now this has been given in this format first list. So this is starting from here, so this is first row, this is second list, so this is second row, this is third list, so this is third row, this is fourth list, this is fourth row, fifth row and sixth row. There are six lists, like this it has been given. Or if we start from 0, then this is 0th, first, second, third, fourth, and fifth. But if I take any position like 36, so here 36 divided by 6, here n is equal to 6. So in this case its value will be 0 and all this value will be 5. It's not coming exactly now. So we have taken position minus 1. If we take here 35, 34 till 30, so all if divided by 6 will be 5. And column value will be what? It will start from 0, 1, 2, 3, 4 and 5. But if we take here for 35, just see here for example, for position equal to 36, or just take 35, it's better. Its row value will be 35 minus 1 divided by n, 34 by 6, that means 5. And column value, I just take here column will be 34 position minus 1, 34 modulo 6, this will be equal to 4. But see here for 34, what is its column number? 0, 1 and 2. Its column number is 2 no? Not 4. But here it is taking 4. Because if it was in increasing order like this, 31, 32, 33, 34, and this was 35, then in that case it might have come 4. But now here this is in decreasing order now. So we will have to check. Here row number is 5. So how will we check? See, for this row its row number is 5. For this row its row number will be 24 divided by 24 divided by 6, its value will be 4. So this is even number. For 24 minus 1, 23, this will be odd number. So whatever are odd number of row here, you can see this is odd number of row, this is odd number of row. That means its value is coming position minus 1, 5. Here it was coming 5, here it is coming 3, here it is coming 1. So in this case all are in decreasing order, 36 to 31, 24 to 19 and 12 to 7. So in that case its column number will be not correct. Okay, so in that case what we have to check, if row modulo 2 equal to 1, then our column should be what? Column should be n minus 1 minus column. Just see for this one, initial column number is 4, n value is 6 here, 6 minus our column will be here, column equal to 6 minus 1 minus 4 equal to 1. And see here the column number of 35, 0 and 1, this is 1. Okay, just take another example. If position equal to, I take for 27. Okay, so for 27 what will be its column number? Sorry, here row number will be for 27, 27 minus 1 divided by 6, 26 divided by 6, 4. So fourth row, this is actually I will update here row also. Row should be n minus 1 minus row, because row will be updated. But here I am taking row value equal to 4. Okay, and here see column should be 27 minus 1 modulo 6, 26 modulo 6 equal to 2. 6 into 4, 24, remainder is 2. Okay, but here see what is 27, this is fine now. Here column number is 0, 1 and 2, so no need to update here, this column number is correct. Okay, then this is fine. For whatever row value is even number, here this row number, final row I will update. So whatever row number initially is even number, So just leave the column number fine. But if row number is odd, then we have to update column number, because in that case that row is in decreasing order. And now again we will update row n minus 1 minus row. So finally this will return our row and column. Okay, now this will return the row and column value. Now what I have to do, I will define one set visited equal to set. This set will store the unique position, store each unique position. Why I am taking unique position? Because I will store only one time each position. And I will define one more dq, q equal to dq. Okay, and inside of this dq I will take the list, and inside this list I will take initial value like 1 and 0. Why 1 and 0? Just say, because we will start from lower position. See, here we will start from here, na, this is ludo, so here we will start from 1. So our initial position will be 1, initial position equal to 1, and this 0 is initial number of moves equal to 0. So in this dq, what we have to store? We have to store position and its number of moves. Whatever position, its corresponding number of moves we have to store inside of this queue. Okay, now I will start from 1 0 always. So I will go inside of this queue dq, while q, at first I will pop this one, its value. So after popping what will come? Position and its moves equal to q dot pop left. Okay, after popping there are two values na inside of this list. Actually this is a list of dq, and its first value is 1 0. So its position will become 1 and its moves will become 0. Okay, now after going here, what I have to do? I have to throw the dice. After 1 I will throw the dice now. So what are the value of dice? 1 to 6. So for I in range 1 to 6, this will go from 1 to 6. Okay, so our new position will be position plus I, whatever the value of dice will come, we will update new position. Okay, so at first I will have to check if new position is greater than n into n. See, n is the value of n into n is here 36. If it is coming greater than 36, then we have to just come outside of this, because it is not giving correct position. No, it can't go 37 here. Then we will find out for each new position its row and column value. How? By calling this function get position. So I will define ry row cy column equal to get position for new position. Before that I have to check, or after this one also we can check, no issue. We have just defined row and column value. We have just got the row and column value. Yeah, here we have to check now. Okay, see what will happen if we go from 1 and dice throw come 1, then it will go to 2, but here it has been given ladder, so ladder will go to 15 now. So we will check in that case. See what is its value given, -1 and 15. This is the last row. So -1 and 15. So if it go on 2, then it have to move to 15. Okay, so we have to check if board corresponding row and column value is not equal to -1. This is not equal to -1, 15. Okay, if this is not equal to -1, then we have to just update the value of this board row and C for position. So our new position will be in this case, just copy this one, board R and C. This will be our new position. Understood? See, if it has come on 2 na, then it have to go to 15. It's fine. Now what I will check, what is our target to reach on 36. So if we reach on 36, so if new position equal to n into n, then we have to return its total number of moves plus 1 because initially it has taken previous moves and now we are taking one move, so it will be 1 added here. So there are three cases now. If it is greater than, then we have to just come outside of this for loop. And if there is any ladder or a snake, so its new position will be updated correspondingly. That means its value is not -1, so its new position will be updated. And after updating new position, if it is coming to destination is n into n, then we have to move total number of moves here. Okay, now we have defined here visited and queue, so something has to done there. So we will check, we have to take only unique position in this visited. So if new position not in visited, if new position not in visited, then we have to add inside visited this new position, visited dot add new position. Okay, this is set, and set can keep only unique values. And we will update queue also, queue dot append its new position and moves plus 1, new position and moves plus 1, because it has come on next move na, so moves plus 1 we have to store. And new position, there is only one value, so I have taken inside this bracket new position moves plus 1. Inside of this queue it will be appended, and for each new value of inside of queue, again we will throw the dice and we will check the condition. If it is coming on our destination, that is n square in minimum number of moves. See, it is storing minimum number of moves only, because what I am taking, if new position not inside a visited, so if it's already visited, if it's already has come, so its move will be lesser, so it will be stored there only. Actually this is the final code. It will again come inside of this while loop, and again it will check for each move and for each dice throw. So its complexity will be here, maximum n square can be if there are no like that, if there are no snake and ladders, then its complexity will be completely n square. That is the worst case. And final, if we don't find the destination, then we have to return -1. Hope this should run correct. Just see again once the code. We have defined this function, length of the board n, this is total number of rows or columns, get position for each position row, position -1, this is integer division modulo. I have taken column. If this position row value is odd, then we have to update column value, and row value finally will be updated, return row and column. visited, and this queue set I have taken visited set and this dq. Starting, we have initially started with 1 and 0, and we have gone inside of this queue and we have popped them. So its position and moves will be stored here, and I have to throw the dice. It will check for 1 to 6. New position will be position plus I. So if new position is greater than n, just come outside of this for loop for that value. And row and column value will we will store here by calling this get position function. So we will check if it is not -1 like this, then we will update the new value of this new position by this board value. If new position is equal to our n square, it is destination, so return moves plus 1. There will be three cases: if it is greater than n or equal to n, or not equal to 1 n. So if not equal to n, then this will come here. We will check inside this visited. If not in visited, then we have to add inside of this visited set, and we will append inside of this dq also. Okay, just run this program at first. Accepted, submit. Okay, it is submitted.